Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, I started and commenced with exercise number 9.2 relevant with chapter number 9 differential equation. In the previous video, I solved the first question of exercise number 9.2 that was totally related with general solution of the first order differential equation. In today's video, I will solve the next question, question number 2 of the same exercise number 9.2 chapter number 9 differential equation FSC part 2 mathematics. So let's move toward lecture number 7 differential equation chapter number 9 FSC part 2 mathematics exercise number 9.2 question number 2. It tells that reduce the following differential equation in separable form and then solve. So it means that in this video we will totally talk on the topic separable differential equation. What is separable differential equation? Let's suppose we have a differential equation is given and we cannot solve that specific particular differential equation using direct integration method. So we use separable differential equation. So let's move toward a part number A. Y dash is equal to y plus x whole square. So move to solution. Y dash is actually the first time derivative of the function y with respect to x. So it means y dash is dy over dx is equal to y plus x whole square. So over here we cannot solve this differential equation for the general solution. So we will use some supposition. Let's suppose I consider this x plus y is equal to variable. Let's suppose I take t. So differentiate both sides with respect to x. Over here we left with derivative of this t with respect to x. Derivative of x with respect to x is 1 and derivative of y with respect to x is dy over dx. Now I need dy over dx, so shift 1 on this side, so my dy over dx will be dt over dx, and this one will shift to the left hand side, it become -1. Now by putting this value and this value in the given differential equation, it becomes dy by dx is dt over dx minus 1 is equal to x plus y whole square. So x plus y is actually t, I suppose, so t square. Now after this shift minus 1 on the right hand side, so we left with dt over dx. So by shifting 1 on the right hand side, it becomes 1 plus t square. Now using separable differential equation, shift 1 plus t square on the left hand side, so it becomes dt over 1 plus t square, and shift dx on the right hand side and take indefinite integral on the both side. So 1 over 1 plus t square integration is actually tangent inverse. Variable is t, so I will write t. So tangent inverse t, integration of 1 is x with respect to dx and plus constant of integration. Now again replace this t with x plus y. So it becomes tangent inverse of t is x plus y is equal to x plus c. So this is actually the required general solution. Now let's understand the next part of part number B. Y dash is equal to tangent of x plus y minus 1. So move to solution of this part number B. Y dash can be written as dy by dx is equal to tangent time of x plus y and minus 1. Again using substitution, let's suppose I consider x plus y is equal to variable t. Taking the derivative of both sides with respect to x, it becomes dt over dx. Derivative of x with respect to x is 1 and derivative of y with respect to x is dy over dx. So put this value in the given differential equation and this value in the given differential equation. So dy over dx from over here, dy over dx will be dt over dx minus 1. dt over dx minus 1 is dy over dx. Put this value. So dy over dx is dt over dx minus 1. Put over here dt over dx minus 1 is equal to tangent time of x plus y. X plus y I suppose t. And after this over here we have extra -1. So -1 cancel out with each other. We left with dt over dx is equal to tangent time of t. Now further shift tangent t on the left hand side, so it becomes dt divided by tangent time of t and shift dx on the right hand side. So take the integral on the both sides, so it becomes 1 over tangent t is cotangent t into dt integral and integral dx. So integral of cotangent t is actually ln of sine t. Because if you differentiate ln of sine of t, it will give us cotangent t is equal to integral of 1 is x plus c. Now I remove this ln, so I will take exponential on the both sides. So taking exponential to the both sides, so exponential and natural logarithm cancel out with each other. We left with sine time of t is equal to, I can write e power x plus c just like e power x into e power c. This is actually this formula. a power m plus n is a power m into a power n. I just split the power x and c and e power x, e power c. So E is a constant, C is a constant. So constant to the power constant will again gives me a constant, another constant. So let's suppose I write C. So it becomes C into e power x is equal to sine time of t. So I replace this t with again with a x plus y. So this is the required general solution. Now let's understand the next part number C. It tells that y dash is equal to x plus e power y minus 1 whole into e power negative y. So move towards solution. Y dash can be written as dy over dx is equal to x plus e power y minus 1 into e power negative y, comes down as it is. Now over here it is e power negative y. So by shifting to the left hand side, the power will become positive. So by shifting on the left hand side become e power y instead of e power negative y into dy over dx is equal to x plus e power y minus 1. Let's suppose this equation passed down. Now I can solve this type of differential equation by using direct integration. So I will use some supposition. Let's suppose I consider e power y is equal to t. Take natural logarithm on the both sides, so it become ln of e power y and it become ln of t. Ln and e will cancel with each other because these are the opposite of each other. We left with y is equal to ln of t. Now differentiate y with respect to x, it become dy over dx. Differentiation of ln of t is 1 over t, but the differentiation of this inner function d, it's the inner function differentiation with respect to x is dt over dx. Now putting this value over here and putting this value, so e power y, I suppose t, so t. dy over dx is actually 1 over t into dt over dx is equal to x minus 1 will come down as it is, and e power y I suppose t, so plus t. T cancel out with t, we left with dt over dx is equal to x minus 1 plus t. Let's suppose this equation second. Now I can solve this differential equation by direct integration. I will again do some supposition. So I consider t is equal to vx. So derivative of t with respect to x is dt over dx. Over here use product rule, so first function derivative, first function v, derivative of this function is 1, so just v, plus second function x, derivative of the first function is dv over dx. Put this value over here, so dt over dx is v plus x dv over dx is equal to x minus 1 plus t, t I suppose vx, so vx. Shift v on the right hand side, so it become negative v and this will come down as it is. X dv over dx, from over here suppose x minus 1 will comes down as it is, and over here take v common, we left with x negative 1 by grouping the term, gives us this. Now using separable differential equation, shift dx and x minus 1 and x on this side and v plus 1 on this side. Using integration it will give us this. Further, ln of v plus 1 is equal to integration of 1 is x, so integration of minus 1 over x is minus ln x plus constant of integration. Remove this ln by taking exponential on the both sides. Over here you left with v plus 1 e power x into e power negative ln x into e power c. E power c will give us another constant c. T is actually from over here v by v is t by x, so I suppose t over x plus 1 e power x, so this minus will move to the power of x, it become x power negative 1 and c. So e power x, e and ln cancel with each other, x power negative 1 into c. T is actually e power y, so e power y over x plus 1 is e power negative x, over here x minus 1 and plus c. Remove this x by multiplying x to the both sides, it become e power y, it become plus x, so over here x and x power negative 1 cancel out with each other, we left with e power x into c. So ey is actually e power x into c minus x. This is the required general solution. Now let's understand the next part number d. Y into dy over dx plus xy square minus x is equal to 0. So move to solution. Y dy over dx comes down as it is. Shift xy square on the right hand side, it become negative xy square. Shift minus x on the right hand side, it become plus x. So now y dy over dx comes down, it is from over here take x common. So over here we left with 1 and over here we left with negative y square. Now by using separable differential equation, shift 1 minus y square on the left hand side, it will move to the denominator. Y dy comes down as it is. Shift dx on the right hand side, it will multiply with x, so x dx, and taking the integral on the both side. Over here I multiply and divide with minus 1 over 2 into minus 2, because these are cancelled with each other, we again left with y dy over 1 minus y square. Now after this step, the derivative of 1 minus y square is present in the numerator, minus 2y. So it means the integration of this whole function will be ln of 1 minus y square, minus 1 over 2 comes on as it is. Integration of x is x square over 2 and plus constant of integration. Multiply this equation by 2, so it become minus ln of 1 minus y square, it become x square, and 2 multiply any constant will give us still a constant c. Shift minus on the right hand side, it become ln of 1 minus y square and it become minus x square, and minus c will again give us plus another constant. So taking exponential on the both side, so over here exponential ln comes cancel out with each other, we left with 1 minus y square and exponential of minus x square plus c. So 1 minus y square, it can be written as e power negative x square into e power c. So e is a constant, so constant to the power constant will again give us a constant. So shift minus y square on the right hand side it become y square, and shift this value on the left hand side it become negative e power negative x square into e power c. So e power c will give us another constant c into e power negative x square and minus into 1 and y square. So this is actually the required general solution. Now let's understand the next part of part number E. dy over dx is equal to y by x plus x square by y square. I cannot integrate I cannot find out general solution for this differential equation. So I will use supposition method. Let's suppose y is equal to vx. Take the derivative of y with respect to x. So dy over dx. Over here use product rule. So first function v, derivative of the second function x is 1. So we left with v. Plus second function x, derivative of the first function with respect to x is dv over dx. Using this value and this value in the given differential equation, so dy over dx is v plus x dv over dx, put over here. So v plus x dv over dx is equal to y is, I suppose, vx. So vx divided by x plus x square divided by y square. So y square will be v square x square. So v square x square. Now v plus x dv over dx, x cancel out with x, we left with v. X square cancel out with x square, we left with 1 over v square. V cancel out with v, we left with x dv over dx is equal to 1 over v square. Shift v square on this side. So over here v square is in a division. So by shifting to the left hand side it will multiply with dv. So v square into dv. Shift dx on the right hand side. It is in division. So by shifting to the right hand side it will multiply. X in multiplication it will move to the division. So v square integration is v power 3 over 3 according to the generalized power rule. Integration of 1 over x is ln x, and we can write ln of c because c is a constant, and if we take ln on the constant it will give me still a constant. So that's why I can take ln on the constant c. So over here product rule will use of the natural logarithm. This c and x will multiply according to the general property of natural logarithm. So v cube over 3 is equal to ln of cxo. Now shift 3 on this side, so v cube is 3 ln cxo. So over here according to the property this 3 will move to the power of cx because cx is base. So cx power 3. So v cube will be ln of, take cube on c and x, so c cube into x cube. C is a constant, so constant power constant 3 will give us still me a constant c into x cube. So v is actually from over here y over x. So y over x whole cube is equal to ln of cx whole cube. Now over here I will remove ln, so I will take exponential on the both sides. So exponential into y over x whole cube is equal to exponential into natural log of cx whole cube. So they cancel out with each other, we left with just cx cube and e power y over x whole cube. This is the required general solution. Now let's understand the last part of today's lecture and the last part of question number 2, part number F. Y minus 3 into dy is equal to x cube plus 1 dx. So this is very easy part of this question number 2. We'll take integral on the both side directly because this can be integrated directly because this is already in separable form. So y minus 3 dy is equal to take the integral on the right hand side also x cube plus 1 into dx. So y integration with respect to dy will be highest power of y is 1. So we will add 1 in the power, so it will become y square, right? The same power in the denominator. And minus 3 times of minus 3 is a constant, so we will take the integral on 1. Integral of 1 with respect to dy is y. Because if you differentiate y with respect to y, it will again give us minus 3 is equal to x cube. Using 1, add 1 in the power, so x power 4. Write the same power in the denominator just like this. And plus integration of 1 is x and plus constant of integration. This is the required general solution. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification and interesting problems related with calculus and mathematics. Thank you.